It's a very natural human instinct to look at something that's moving incredibly fast and just assume that eventually it has to run out of gas.
Right. Yeah, like a sprinter.
Exactly like a sprinter. You watch a runner sprinting down a track, and inherently, they are going to hit a wall.
They have to. Biology literally demands a pause.
Right. Lactic acid builds up. They have to catch their breath. And we apply that exact same logic to almost everything we observe in life.
We really do. I mean, the economy goes through boom and bust cycles, city populations surge, and then, they stabilize.
Yeah. And right now, we are applying that identical expectation to technology. We just naturally assume the current pace of change will eventually slow down or plateau or, like we said, hit that inevitable wall.
But the real question is, what if the very biological brain you were using to make that assumption is physically incapable of understanding the actual speed of the future?
Which is such a wild thought.
It forces you to really step back and examine the basic equipment we use to perceive reality.
Yeah.
Because if our fundamental baseline for measuring progress is flawed by our own biology, then every prediction we make about, the next 5 to 10 years is going to be wildly off the mark.
We basically end up preparing for a future that won't even exist. And that brings us to the core of our deep dive today. We are looking at a recent piece from Technology Review featuring Mustafa Suleyman.
Yeah, and for anyone following the artificial intelligence space, Suleyman is a massive figure.
Huge. Co-founder of DeepMind, someone who has literally been in the engine room of this technology from the very, very early days.
Right. And his core argument in this article is it's honestly a massive wake-up call.
It really is. The mission of this deep dive is to unpack his unequivocal statement that AI development is not going to hit a wall anytime soon. There is no plateau coming.
And the friction really begins when we try to process that claim.
Mm-hmm.
Because Suleyman's premise relies on understanding those biological blind spots we just mentioned.
Right. He points out that human evolutionary instincts are honed exclusively for linear experiences.
Exactly. I mean, for hundreds of thousands of years, our survival depended entirely on understanding things that moved in straight, predictable, additive lines.
Like tracking a prey animal across a savanna
Or calculating the trajectory of a thrown spear.
Mm-hmm.
Or even just anticipating the changing of the seasons. It's all linear.
And Suleyman uses this very grounded example in the text to illustrate this, which I love. He talks about judging the act of walking a certain distance over time.
It's so mundane, but it perfectly captures our limitation.
Yeah, because when you walk, you take a step and you move a couple of feet. You take another step, you move another couple of feet.
The progress is strictly additive. It's just 1 + 1 + 1.
Exactly. And your brain is an absolute master at calculating that specific type of momentum.
Oh, totally. If you see someone walking towards you from across a field, your visual cortex just effortlessly calculates their speed.
Right. You predict exactly when they're going to reach you. You don't even have to think about it.
Because that's linear calculation.
Yeah.
It's built right into our hardware.
But, and this is the kicker, Suleyman argues the current wave of technological development does not follow those rules at all.
Not even a little bit.
To make this really visceral for you listening, if I take 30 linear steps, just regular walking steps, I'm basically across the room.
Right. You can visually see the other side.
Yeah, I can comprehend that distance perfectly, but if I take 30 exponential steps...
Which means every step doubles the distance of the last one.
Right. So step 1 is a foot, step 2 is 2 feet, step 3 is 4 feet. By the time I take my 30th exponential step, I'm not just down the street.
No, you're orbiting the Earth.
I'm orbiting the Earth. And that is just, our brains are built for the room. They are absolutely not built for the orbit.
We literally lack the intuitive cognitive machinery to instinctively grasp exponential growth. It just feels entirely unnatural.
Yeah, when we hear the word exponential, we usually just think really fast linear growth.
Exactly. We don't internalize that the rate of change is actively compounding on itself.
Which means when we project the future of AI, we subconsciously map it right back onto that linear step-by-step progression.
We expect the AI of tomorrow to be just, a little bit better than the AI of today.
Just like your next step is only a little further than your last step. And because we expect that linear progress, we inevitably expect the plateau.
Right. We expect the technology to encounter friction and just slow down, because literally everything in our natural world encounters friction.
But Suleyman is sounding the alarm that this specific cognitive bias is incredibly dangerous.
It is, because by projecting our evolutionary limitations onto machine development, We completely blind ourselves to the reality of the exponential curve.
We are sitting there looking for the runner to get tired, completely ignoring the fact that we aren't watching a runner anymore.
Right, we are watching an engine that generates its own fuel.
So if our brains are hardwired for a 3 mile per hour walking world, what happens when we are forced to build tools that operate at orbital speeds?
Well, Suleyman points out that AI thrives precisely on these exponential trends.
Specifically, he mentions the compounding advancements in computing power and data processing capabilities.
Yeah, and we have to be clear, these are just incremental upgrades.
Right, we aren't just making a slightly better computer every year.
No, the dynamic at play here is what's known as compound scaling laws.
Hmm.
You have computing power growing exponentially, literally doubling in capacity at staggering rates.
And simultaneously, the data processing capabilities are also growing exponentially.
Exactly. We are feeding these systems more information than humanity has ever generated in its entire history.
And giving them exponentially more powerful engines to process it all. The models get bigger, the compute gets faster, and the error rates just drop predictably time and time again. But wait, I have to jump in here and play devil's advocate for a second.
Sure, go for it.
Because I think a lot of people listening probably have this exact reaction. A faster calculator doing math a billion times faster still just gives me the answer to the math I asked for, right?
Right, that's the common assumption.
Like, larger hard drives and faster chips are great, but isn't more data just, well, more data? At what point does a hyper-fast calculator actually transform into the science fiction scenario that Suleyman is warning us about?
That is exactly the core misunderstanding most people have about modern AI. It's not a calculator.
Okay, explain that.
Well, a calculator requires a human to input the exact equation and explicitly define the rules of the operation. You tell it what to do.
Right.
But Suleyman specifically highlights that we have crossed a threshold into systems that can autonomously learn complex tasks.
Right.
We are no longer programming the rules.
We are just feeding it the raw data and letting it infer the rules itself.
Yes, it's exactly the opposite of traditional programming. Instead of telling the machine, 2 plus 2 equals 4, researchers feed a neural network millions of examples of numbers interacting.
Right. And the system builds its own internal logic to understand addition.
Exactly. And it obviously doesn't stop at basic math. The models Suleyman discusses can predict wildly intricate patterns in massive data sets.
So when you have a machine that can process an unimaginable amount of data, find patterns that a human could never see in 1,000 lifetimes.
And then autonomously learn from those patterns to improve its own internal logic.
Yeah, the nature of the tool changes fundamentally. It transitions from a tool you wield to an entity that learns.
And this brings up the concept of emergent behaviors, which, researchers talk about all the time now.
Yeah, where you scale up the compute and the data, expecting the AI to just get a little better at predicting text.
And suddenly, without anyone explicitly programming it to do so, it teaches itself how to write functional Python code.
Or it passes the bar exam.
Right. Because the computing power and the data pools are growing exponentially, the speed at which it uncovers these emergent skills is accelerating.
The growth trajectory literally feeds on itself. The AI uses its current pattern recognition abilities to design more efficient ways to process the next batch of data.
And when machines move from simply retrieving data to autonomously learning complex tasks and exhibiting these emergent behaviors, they start stepping onto turf that we previously considered exclusively human.
Yeah, Suleyman argues the future holds limitless possibilities, but the direct consequence of that is a profound blurring of the lines between human creativity and machine intelligence.
And this is where the technical reality crashes right into our societal identity.
Oh, big time.
When we see an AI generate a deeply emotive piece of music or a photorealistic image of a city that doesn't exist, our immediate human defense mechanism is to just dismiss it.
We say, oh, it's just remixing what humans have already done. It's just a really complex autocomplete.
Yeah, we frantically try to protect the sacredness of human creativity by minimizing the machine's output.
Okay, but let me push back on Suleyman here, because this touches a very raw nerve for a lot of people.
It does. It's uncomfortable.
Does this completely cheapen what art and invention actually are? Like, if an AI can compose a symphony simply by predicting intricate patterns in a data set of historical music, is he suggesting that human genius, someone like Mozart or Beethoven, is just biological math?
It's a tough pill to swallow.
Are our greatest visionaries just really good linear pattern recognizers, and the AI is merely doing the exact same thing, just exponentially faster? Because, frankly, that feels incredibly reductive.
It definitely feels reductive. I completely agree. but we really have to dissect what creativity actually is at its mechanical core.
Okay, how so?
Well, often human creativity is simply the ability to connect seemingly unrelated dots. It is taking an influence from, say, architecture, combining it with an observation from nature, and applying it to a problem in engineering.
Right, synthesis.
Exactly. And a human brain can hold maybe a dozen major influences in its working memory at any given time.
While the AI can hold the entirety of recorded human history, art, and science in its working memory simultaneously.
Yes. And it navigates the latent space between all of those disciplines. So if creativity is really about connecting dots and recognizing novel patterns, an exponential machine with access to all human data will inherently become a master of that domain.
So it doesn't need to feel anything to make something new.
Right. The AI doesn't need a mystical, uncomputable soul to produce outputs that are indistinguishable from or even vastly superior to human creative work. It just needs scale.
Think about the practical implications for, like a graphic designer today. The AI isn't just copying past logos, it is actively interpolating.
It analyzes the aesthetic principles of 1920s Art Deco, the color theory of 1980s synth pop, and the modern minimalist trends of tech startups.
And it synthesizes an entirely new aesthetic that perfectly balances all three in a matter of seconds.
Which forces a complete redefinition of human value in industries and societies. I mean, if a machine can autonomously learn to design a more efficient aerodynamic shape for a vehicle, or draft a perfectly watertight legal contract, the economic structures built around human expertise have to adapt.
The lines blur because the output is genuinely creative and novel, even if the process generating it is just a sprawling, multi-billion parameter mathematical model.
And it forces us into an existential corner.
Yeah, if we are no longer the most capable pattern recognizers on the planet, where do we fit?
If the machine is orbiting the Earth while we are literally still walking across the room, what is our role in the landscape of tomorrow?
Which is terrifying. But Suleyman doesn't present this exponential acceleration just to provoke existential dread, right?
No, not at all. He provides a framework for how we have to respond. His ultimate call to action is that we need to fundamentally recalibrate our expectations.
We have to embrace a massive mindset shift and recognize that we are at the cusp of unprecedented technological evolution. But, okay, if you are listening to this right now and thinking, okay, my brain isn't wired to understand the speed, my creative skills might be replicable by a math model, and the finish line is moving at light speed.
The natural reaction is total paralysis.
Total paralysis. It is incredibly easy to read a phrase like embrace a mindset shift in an article, but practically, how do you actually accept that the technology around you is growing exponentially without feeling entirely overwhelmed by info overload?
It's a great question. And I think the realization here is that the anxiety we feel doesn't actually come from the technology itself.
Oh, interesting. Where does it come from?
The anxiety comes from the severe friction between what you intuitively expect to happen and what is actually happening.
Ah, the linear expectation again.
Exactly. As long as you maintain a linear expectation, as long as you stubbornly expect the technology to eventually hit a wall, slow down, and give society a decade to catch its breath and regulate, you are going to be constantly violently shocked every time it doesn't.
So you wake up every single morning feeling like the ground is shifting beneath your feet simply because you keep waiting for a plateau that does not exist.
Abandoning the plateau is the mindset shift. Recalibrating your expectations means accepting, at a foundational level, that the boundaries and limitations of yesterday have no bearing on today.
Rapid, unprecedented compounding change is just the new baseline.
Yes, and once you stop expecting a wall, the overwhelming nature of the change actually starts to dissipate.
You transition from a state of perpetual shock to a state of engaged observation. You just stop fighting the current.
You stay curious rather than fearful. If you accept that the lines of human creativity are blurring, you don't view it as a loss of your identity. You view it as an expansion of what is possible when you partner with these systems.
The value shifts from the human executing the pattern to the human directing, curating, and prompting the system that executes the pattern.
Exactly. You don't need to biologically calculate the orbit. You just need to be mentally flexible enough to strap in for the launch.
That is such a powerful way to frame it. Let's briefly bring all these threads together for everyone listening.
Good idea.
We started by looking at our own biology, identifying the evolutionary trap of linear thinking. We are built to understand the world at a walking pace, step by steady step.
Which creates a massive blind spot when we try to predict the trajectory of exponential movement.
Right, and then we examine the engine of AI, exploring how the compounding forces of computing power and data aren't just building faster calculators.
No, they are creating probabilistic models capable of autonomous learning, emergent behaviors, and intricate pattern prediction across vast, unimaginable scales.
Which brought us to the real friction point, the uncomfortable reality where machine intelligence intercepts human creativity. The realization that if creativity is simply connecting disparate dots, a machine with the entirety of human knowledge at its disposal will connect dots we didn't even know existed.
And finally, the absolute necessity of abandoning our expectation of a technological plateau if we want to survive this era psychologically intact.
But looking at Suleiman's premise in its entirety, it actually forces a final, deeply unsettling scenario to consider.
It really does. Because if human understanding is strictly bound to a linear pace, and AI development is exponentially accelerating into, as he calls it, limitless possibilities.
What happens when AI's autonomous learning creates a vital solution to a global problem? But the pathway it took to find that solution is so complex that our linear brains literally cannot comprehend the logic.
Exactly. If the machine hands us a revolutionary new material or a cure for a disease, but the mathematical reasoning it used to design the molecule is entirely incomprehensible to our absolute smartest scientists.
Are we actively building a future that we will entirely rely upon but fundamentally be unable to understand?
That is the paradox we are stepping into. If the answer is in orbit while our comprehension is still walking across the room, do we trust the answer?
Wow. It is a staggering thought to leave on. Breaking down our biological limits, the nature of creativity, and the exponential curve has been an incredible journey today.
It really has.
Thank you all for joining us on this deep dive. Take that final question with you, stay curious, and keep imagining the possibilities of tomorrow.